Welcome back. We're in chapter 15 now on oxidation and reduction. And oxidation and reductions, along with acid-base chemistry, is some of the most common chemical reactions that you actually have in chemistry. In an acid, you are transferring a proton. In an oxidation reduction reaction, you are transferring an electron. So either a proton is going to be transferred to another compound or atom, or an electron will. And so this is extremely common and really interesting too. So let's get started. Oxidation reduction, I think of it like a baseball game. I think of an electron as being something that can be transferred, and if you get rid of an electron, you get rid of part of your negative charge, and that means you become more positive. So if you are more positive, that is what is called oxidized. So oxidized comes from oxygen, which is what was first studied when these equations were first looked at and identified. Oxygen being one that oxidizes more than most others that were first studied. So oxidation is when an electron is taken or donated to another species of some type, and that atom becomes more positive. The opposite of that is reduction. If you take an electron, your charge drops because you've taken on a negative charge, and so your negativeness goes down. Your charge goes down to more negative because you've taken on that negative charge, and you have become reduced. So normally what happens is one atom will transfer an electron to another atom. That atom that gives it away becomes oxidized and its charge increases. The atom that receives it will become reduced and its charge decreases. Oxidation reduction reactions are all over the place. All batteries are oxidation reduction reactions. All rusting or food spoilage or your nervous system, it happens all the time because it's the smallest unit of matter, and as it's transferred around, that's really what is causing such a lot of chemistry. So the picture here is of rusting tools. All rust and patinas on metals, all those are all oxidations. Spoiling food or rotting of apples, all that is oxidation reduction. Batteries, yeah. So what we see is that if an electron is donated, it's lost. So here's a mnemonic that may help you. Oxidation is loss of electrons. So oil, okay. Reduction is gain of electron, rig. So if you can remember oil rig, oxidation is lost, reduction is gain of electrons. Okay, so in the example given here on this page, zinc metal, which is neutral, if two electrons are stolen, it will become a zinc ion and then can join up with some kind of a negative anion to make a compound. So zinc by itself is not a compound, but if it becomes an ion and then joins up with an anion, then it becomes oxidized. If something takes that electron so that it becomes more negative, then then that's called reduction. So what's going to happen is if you take an electron, you become reduced because your charge drops, and you have done something to the other species. So for instance, if you yourself become reduced by taking that electron from something else, you've made it oxidize. So there's a connection between whatever takes an electron and whatever donates the electron. So there is a kind of a one has the ball or the other has the ball, and that's why I see it a lot like a ball game. So here is an example. This is just one of millions of different examples you could give for this. In a single replacement reaction, zinc, Okay, if you have, for instance, zinc metal, and you put it in to something like a copper solution. Let's say you put it in copper sulfide or copper sulfate, which is a blue solution. You put zinc metal in it, the zinc will actually dissolve and the copper will plate onto the zinc. And so you'll pull the copper right out of the solution and then the zinc will dissolve into solution. That's what's happening when you're replacing it. It's a single replacement. The zinc is a metal to start with, but it's an ion at the end. It's a cation. That means it's positive. And so how do you get more positive? You lose electrons. So the zinc becomes oxidized. The chlorine or the copper that's in the solution to start with is in solution, so it's copper sulfide. So it's already a cation. It takes the 2 electrons from the zinc, becomes copper metal. That's why the zinc will be copper plated, and then as a result, you're going to have copper metal deposited, and the zinc go into solution. So the color of the solution will change. So what's happening? The overall equation would be zinc metal plus copper ions will yield zinc ions and copper metal. Okay, so the electrons that make it neutral will be stolen or donated depending on which way you're going. So here's the example I was telling you about. The copper chloride is a blue solution. Okay, it's very blue, and the zinc is simply a silver metal. It's a very light silver metal. If you put that zinc in a copper sulfide solution, the copper will actually pull out of the solution and deposit on the outside of the zinc. And so you're going to get a copper coating on the zinc. So what's happening at the atomic level is the copper 2 plus ion, which is in solution, meets up at the surface of the zinc. Here's the zinc atoms that are in that metal. And you're going to get a stealing of electrons. So what will happen is the zinc has the electrons right now. The copper doesn't have them because they're already positive, so the electrons are gone. So the zinc has them, and so 2 electrons will go from the zinc atom to the copper. The copper is now a metal, it's deposited, and the zinc ion that used to be there is now in solution. So it's not just that there's copper on the outside of the zinc. The zinc is actually being eaten away and the copper is being laid down in its place. And it may not be beautifully in its place like this. It may be lumpy and all over the place. But for every copper that comes in, 1 zinc goes away. So the whole metal kind of gets eaten away. So this, I hope, is a good introduction, and we'll certainly do more later.